Okay, so you're getting ready to speak at AI CodeCast, and you need to explain this classic coding problem, reverse nodes in K group.
Oh, yeah, that's a good one.
We've got your back with this deep dive.
Yeah.
It's all about linked lists and, manipulating them in kind of a tricky way.
Tricky but fun.
Yeah.
Really gets you thinking.
So let's just briefly describe the problem, just in case someone out there is like, reverse what?
Yeah, so basically you've got a linked list, right? Just a chain of nodes. Each node has some data and then a pointer to the next one in the line.
Yeah.
And you have this integer k, and your job is to reverse the nodes, but in groups of k.
Right. So it's not just like flipping the whole list. It's like these little chunks.
It's like little chunks, exactly.
Like dealing cards into piles.
It's exact. Yeah, think of like a deck of cards. You deal them out into piles of k.
And you're reversing the order within each pile.
Yeah, exactly. And if you have any cards left over at the end, if they don't make a full group, you just leave them as they are.
Yeah. So it's like this combination of, reversing, but also grouping.
Yeah, and that's where the pointer manipulation comes in. It's not as simple as just swapping the entire list.
Right. Right. You got to be clever about it.
And the real challenge for your AI CodeCast talk, I think, is doing this with the least extra memory possible, using what we call O1 space complexity, like a constant amount of space, no matter how big that linked list gets.
Right. Which is super important because we're talking about real world applications here where you might have, massive data sets.
Absolutely. Efficiency is key.
So let's jump into an example from your AI CodeCast prep materials.
Okay.
So we've got this list, 1, 2, 3, 4, 5.
Okay.
And let's say K is 2.
Okay.
What would the output be after reversing the nodes in groups of 2?
So you get 2, 1, 4, 3, 5.
Oh, okay.
See how the first two nodes are swapped, then the next two.
Right, right.
And that last node, 5, it's just left alone because it doesn't have a partner to swap with.
Yeah, it's the odd one out.
Exactly.
And if K was 3 in that same list, you'd end up with 3, 2, 1, 4, 5.
Right.
Because now the last two are left alone because they don't form a full group of 3.
Yeah, exactly.
So before we get into, the fancy pointer stuff, what about, what's the most straightforward way someone might try to solve this, even if it's not, the most elegant solution?
Yeah, well, I think the most straightforward way is to just create a brand new linked list.
Just start fresh,
Yeah, traverse the original list,
grab your group.
grab the groups of K, reverse them as you go, and just add them to this new list.
Okay.
And then if you have those leftover nodes at the end, you just tack them on as is.
Yeah.
But the problem with that is you're using a lot of extra memory to create that whole new list.
Right.
Especially if the original list is huge, that can be really inefficient.
Yeah, and that, if you're giving this talk at AI CodeCast, that's probably not what you want to be talking about.
No, you want to talk about the clever stuff, the efficient stuff.
Exactly. So let's ditch the brute force and move on to the good stuff.
The iterative approach.
The iterative approach.
With the O1 space complexity.
Yes, where we're really using, a minimal amount of extra memory.
Exactly. And it's all about cleverly manipulating those pointers within the linked list itself.
Okay, I'm intrigued.
Yeah.
Where do we even begin with that?
Well, it all starts with understanding the role of 4 crucial pointers. They're like our tools for rearranging this linked list.
Ooh, okay, 4 pointers.
Yeah. So first we have, think of it like a guide. We have head, and this is pointing to the beginning of the current group of K nodes we're working with.
So as we're moving through the list, head is kind of like our starting point for each chunk.
Yeah, exactly.
I like it, a guide.
And then we have rev head. This one's a bit more, it's pointing to the reversed section of the list. It's always pointing to the end of the reverse section, which becomes the new head of that group once it's flipped.
So it's kind of like as we flip each group, rev head is keeping track of where that new beginning is.
Exactly.
Okay, I'm following.
All right, now for the clever ones, we have gek tail, which acts as a connector, like between those reversed groups. It points to the tail of the previous reversed group.
So it's like we reverse a group, and then Daykel is like holding onto the end of that so we can attach the next one.
Precisely. Imagine it like a train coupler linking those reversed cars together.
Oh, I like that analogy. Okay, Daytail the coupler. Got it.
Yeah, and lastly, we have new head, which is our overall map. It keeps track of the head of the entire modified list, the final result that will ultimately return.
So new head is like the big picture,
Right.
while these other pointers are kind of working within their little sections.
Yeah, it's all about working together.
I like it. Okay, so we've got our pointers all set up, each with their specific job to do. But now, how do we actually do the reversing within each group of K? Like, that's where I imagine things get really tricky.
It does require some careful pointer manipulation, but it's not as daunting as it might seem.
Okay.
We're going to move through the list in chunks of K-nodes, right? And for each chunk, we'll first check, do we actually have K-nodes left?
Right, because you might have some stragglers at the end.
Exactly. If we don't, we just leave those alone and move on.
Okay.
But if we do have enough nodes,
Then the real fun begins, the pointer dance.
that's right.
So break it down for me. What are those steps?
So the first step is to reverse the links within that current K-node group. Imagine it like taking those K-nodes and flipping them over like a stack of pancakes.
Okay, I like that, pancakes.
We're going to use our pointers to carefully rearrange the next pointers of each node,
Right.
and that effectively reverses their order.
So we flipped our pancake stack, now what?
Now we got to connect it back into the list. That's where our trusty Kershaw comes in. Remember, it's pointing to the tail of the previous reversed group.
Right, our coupler.
Exactly. So we connect the tail of our newly reversed group to the head pointed to by a tail, and boom, they're linked.
Oh, okay, so it's all about making those connections.
Exactly. Then we update 8-tail to point to the tail of the group we just reversed. Head moves on to the next group, and we keep doing this until we've gone through the whole list.
Mm-hmm. It's starting to make sense, but I gotta admit, I'm still a bit fuzzy on how we actually do the link reversing within each group.
Yeah.
Like, how do we actually swap those pointers around?
Let's break that down a bit more. Imagine we have a group of 3 nodes that we want to reverse, node 1, node 2, and node 3. Initially, node 1 is pointing to node 2, and node 2 is pointing to node 3.
Right, standard linked list stuff.
Now, let's introduce a temporary pointer. We'll call it prev, and this is going to help us with the swapping.
Okay.
Initially, prev is going to point to the node before our group of 3.
So, like, if it's the very first group in the list, prev would just be NULL. Wow.
Exactly. It's like our anchor to the part of the list we've already dealt with.
Got it.
Okay, so here's the swap. We start with head pointing and node 1.
Okay.
First, we store node 1's next pointer, which is currently pointing to node 2 in a temporary variable.
Okay, so we don't lose track of node 2.
Yeah, we don't want to break the chain.
Right.
Now, we update node 1's next pointer to point to prev.
So now the first node in the group, node 1, is pointing back to the previous group, or to NULL if it's the first group.
Exactly, first reversal done.
Okay.
Now we update prev to point to node 1, basically moving prev forward, getting it ready for the next swap.
So prev has kind of shifted one position to the right.
Yeah, and we also need to advance head so that it's ready to point to the next node we want to swap.
Right.
So we'll update head to point to node 2, which is the node that was originally after node 1. Remember, we stored that in our temporary variable earlier.
Okay, so we use that temporary variable to keep head one step ahead of prev.
Exactly. And now we just repeat this process. Head is at node 2, prev is at node 1. Store node 2's original next pointer, which is pointing to node 3, in our temporary variable. Then update node 2's next pointer to point to node 1, where prev is currently pointing.
So now both node 2 and node 1 are pointing backwards.
You got it.
Node 2 to node 1, and then node 1 back to whatever prev was pointing to before.
Exactly. And we continue. Update prev to point to the current head, which is node 2, and update head to point to the node stored in our temporary variable, which is now node 3.
And we've reversed 2 of the links.
Yes.
See how we're systematically kind of flipping the direction of those pointers?
Exactly, step by step.
Okay.
And actually, in this example with 3 nodes, we're already done with the reversing within this group.
Oh.
Node 3, which head is now pointing to, will automatically become the new tail of this reversed group.
Got it. So we flip the links within the group. Now the big question is, how do we connect this back into the main list?
That's where our trusty 8-tail comes in. Remember, it's been waiting patiently, pointing to the tail of the previous reversed group.
Right. Our coupler, ready to go.
But we got to make sure it connects to the correct node in our newly reversed group, and that's the original last node in the group, which becomes the new first node.
Oh, of course. So head is now actually pointing to the tail of the reverse group.
Exactly.
So if we want to connect tail to the new head of this reverse group, we need to figure out where that new head is.
And that's where prev comes in handy again. Remember, prev is always one step behind head. So after all our swapping, prev is now pointing to the new head of the reversed group.
Ah, clever.
So if kektail is not NUL, meaning we're not at the very beginning of the list, we update its next pointer to point to prev, which is the new head of our reverse group.
Okay.
And to get ready for the next group, we update gaktail to point to the tail of the group we just reversed.
Which is where head is already pointing, right?
Exactly. So we just make K point to the same node as head. Got it. And one more thing, remember new head, our pointer to the very beginning of the whole modified list. If this was the very first group we reversed, we need to make sure new head is now pointing to the new head of this group, which again is where prev is.
Right, got to make sure we don't lose the starting point of the whole thing.
Exactly, and that's basically it.
So we've reversed a group, linked it back in, made sure new head is pointing to the right spot. What happens next?
We just move on to the next group, update head to point to the node after this group, and we do the whole process again.
Check if we have enough nodes, reverse, connect, and so on.
Exactly, until we hit the end of the list.
This is really cool.
It's elegant, right?
Yeah, like, it's a lot of pointer manipulation, but it's actually quite logical once you break it down.
And for your AI CodeCast talk, really emphasize how important this O1 space complexity is, especially when you're dealing with huge data sets.
Yeah, because you don't want to be using up all your memory just to reverse a linked list.
Exactly. You want to be efficient.
So speaking of being practical, should we move on to the pseudocode?
Yeah, I think that's a good idea.
Like, let's see how this all looks in a more concrete form.
Let's do it.
Okay, so pseudocode time. Let's see how this iterative solution actually looks in practice. We're not going to get bogged down in like specific syntax or anything, just the logic.
Right. Keep it high level for that AI CodeCast audience.
Yeah, exactly. Clarity is key here.
Yeah. So let's start with our main function. We'll call it reverse group. It'll take two inputs, the head of our linked list and the integer k, the size of those groups we want to reverse.
All right, so we've got our function set up. What's the first move?
First thing, gotta initialize our 4-star players. Head, kale, rev head, and new head.
Oh, pointers, yeah.
Our trusty pointers.
We're ready to go.
So we set head to the head of the input linked list. That's our starting point.
Makes sense.
And then in a tail, rev head, new head, we set them all to NELL because we haven't reversed anything yet.
Right, they're just waiting to be assigned.
Exactly. Now, the main part of this algorithm is a loop. It's going to iterate through the list, processing k nodes at a time. We'll use a while loop. Keeps going as long as head is not NUL, meaning we haven't hit the end of the list.
Okay, so while we still have nodes to process.
Yeah, and inside this loop, we first got to check if we have enough nodes left for a full group of k.
Right, because if you don't, you just leave the rest as they are.
Exactly. So how do we do that in the code?
Well, we could use a counter variable, call it count, and start it at 0.
Yeah, count equals 0.
And then use another loop, like a for loop, to go through k nodes starting from the current head.
Right.
And inside that loop, we check two things. First, if we hit the end of the list, like if head becomes NUL.
Yeah, if that happens, we break out not enough nodes for a full group.
Right. And second, if we haven't hit the end, we bump up our count and move head to the next node.
Increment that count, keep moving.
Okay, so if we get through all k iterations of that inner loop without hitting the end, we know we've got a full group to work with. But if we hit the end early, count will be less than k.
Right, so after this inner loop, we check count.
Okay.
If it's less than k, we're done. We break out of the outer loop too, no more full groups to process.
But if count does equal k,
then it's showtime. The pointer swapping routine comes into play.
Pointer dance.
Remember, our temporary pointer, prev, helps us with the swapping.
Mm-hmm.
We initialize that to NLL at the beginning.
Our anchor.
Our anchor, right. So now another for loop to iterate k1 times. We only need k1 swaps to reverse a group of k nodes.
Oh, right, okay.
And inside this loop, we do our pointer magic.
Right, break it down for me one more time.
So for each swap, we first store the original next pointer of the current head node in a temporary variable, let's call it next, so we don't lose track of what comes after.
Right, got to keep that chain intact.
Then we update head's next pointer to point to prev.
Flipping the direction.
Exactly. Then we update prev to point to the current head node, moving it forward.
One step at a time.
And finally, we move head forward too, update it to point to next, that temporary variable where we stored the original next node.
Okay, so we're systematically reversing those pointers.
Step by step.
So after k1 swaps, the group is fully reversed.
Right, and now, time to connect it back to the main list. This is where eggtail comes in.
Our coupler.
If eggtail is not NULL, meaning it's not the first group we reversed, we update its next pointer to point to prev, which is now the new head of our reversed group.
Ah, connecting the tail of the previous group to the head of the new one.
Exactly. And then we update tail to point to the tail of the group we just reversed, which is where head is currently at.
Getting ready for the next one.
Right, and don't forget about new head.
Oh, right, our overall starting point.
If this was the first group, we update new head to also point to prev.
Got it. So we don't lose track of the beginning of the whole modified list.
And that's it. Group reversed, linked back in, pointers updated, all ready for the next one.
That was really clear. I think I could explain that at AI CodeCast now.
Good, I think you're all set.
And the pseudocode really helped to visualize it.
Yeah, it's a good way to break it down.
Absolutely. And, really emphasize that O1 space complexity. That's going to be a big selling point for the AI CodeCast folks.
For sure. Efficiency is key.
Well, I think we've covered it, folks. Our deep dive into reverse nudes and K-group, from the problem itself to the brute force approach, and then this really elegant iterative solution.
It's been fun walking through this with you.
Yeah, I feel like I've learned a lot, and hopefully our listeners have too.
I hope so.
So to all our listeners out there, thank you for tuning in. We hope you feel ready to tackle this coding problem and impress everyone at AI CodeCast. Until next time, happy coding.